Okay, everybody. Welcome to the December the 16th wasmCloud community meeting, where we're trying to enable developers to build their function and services in WebAssembly and run them everywhere. And I think we've got a couple new folks joining this week. Andrew, Mingshu, do you guys mind just doing a quick little intro and letting us know what you work on?
Mingshu, you want to go first?
Yeah. Mingshu Sang, I'm a senior principal engineer at Intel. I'm also representative for Intel in the BICO Alliance, and I work with Andrew on neural network for the WASI and a bunch of other stuff.
Awesome. Thank you guys for coming today. Andrew?
Hi, I'm the non-senior partner, so I'm the I'm a software engineer at Intel. I work in Mingshu's group, and I did a lot of the implementation for WASI-NN and plugged in with WASI and Wasm time and stuff like that.
Okay, that's awesome. And in keeping with some of the suggestions we got, I think we're going to try to stick with starting out with a demo. Radu, are you ready to hand it over?
Sure.
Great.
I'll try to keep it as brief as possible. So in short, this is about adding experimental support for Berkeley sockets in the WASI API. And I did a write-up for that. I think you had the link to the URL blog post in the notes. But in short, I want to point out that this is mostly built on top of the current proposal to add sockets to the WASI API. There's an open pull request with the Witix API definitions, and it is mostly based on this implementation. And there's also a work in progress implementation for that API as well. I like to point out that this has been somewhat sold out in the last couple of months, but the implementation is there, and there seems to be a consensus about its about the API so far. And I also want to point out that there's one blog post from Kawamura Yoto, which has been extremely helpful in all this process. He's documenting adding networking for line engineering's platform. And his blog post is really, really great. I link to all of these in my blog post. So in short, I'd like to start with pointing out how the WASI API is defined. So if you go into the wasmTime repo, wasmTime is the bytecode alliance implementation for WASI, is a WebAssembly runtime outside the browser. There are some mentions for sockets. Essentially, there's an API for socket receive and one for socket send, but they're unimplemented, and then there's no way to actually start a socket connection. So the first thing we have to do in order to add trouble hearing you. Sorry about that. Is to add a socket connect function to the WASI API. This adds it to the WASI snapshot preview. For people who are familiar with the ephemeral states in WASI, you could add it in the ephemeral state, but this just makes it easy because it's one giant file. It's not much of a difference whether you add it to the ephemeral or to the preview. We add a socket connect function, which takes an IP address, a port, and then returns a file descriptor. We also have to actually implement it in WASI, and this is the main reason why I don't recommend anyone using this particular implementation in production. This just starts a TCP stream and returns its file descriptor. It doesn't take capabilities into account. It doesn't check for available capabilities and things like that. It's just a proof of concept that we're able to actually start a socket. And also implementing the socket receive and socket send on top of essentially Rust TCP streams. So the WebAssembly module requests a new socket, and then wasmTime actually creates the TCP stream and returns its file descriptor back to the WebAssembly module. So we have a build of wasmTime with this new API, and then right now we're at the point where we actually want to implement this in other WebAssembly implementations. So the easiest one to get started, I would say, is trying to implement this in something like AssemblyScript. And there's also a branch that adds a new socket to AssemblyScript through AS WASI, which is a WASI shim for AssemblyScript. that's built by the community. So essentially implementing connect, write, and receive on assembly script sockets. And if we try and actually build that, then let's start a sockets server locally. And basically, after we actually implement the socket, we can create a new socket that connects on localhost and essentially write and receive things from that socket. So if we build this WebAssembly module and start the new socket, we can actually see integrating with Wasm time, and we're sending some bytes to through Wasm time to the server, and then we're receiving from it. And now that we have the basic way of sending and receiving things on that socket, we can, if we want, we can build things on top of it. So if someone wanted to build an HTTP client for assembly script, for example, they could essentially build on top of the text socket. That seems to be so we can, it's essentially being a TCP stream, we can proxy anything we want on that. So this is just a result from an HTTP server. Going forward, we can also implement this in the Rust standard library. This is, it requires a fork of the Rust compiler and standard library, so I wouldn't recommend anyone doing that just yet. We'll just have to wait for upstream support in Rust. But if you wanted to, this is how we would do it. The same basic thing, patching the Rust standard library to use WASI sock connect instead of directly starting a TCP stream. So take the file descriptor from WASI sock connect and then actually starting a TCP stream. And
can I pause you real quick here and ask what may be an obvious question?
Sure.
On line 35 there, you're using WASI sock connect, but you're not checking to see what your compile target platform is. Is that just because you're on a hard-coded fork, or is that because the code is organized differently?
This is the Rust standard library has different targets for different architectures.
So that entire file means that you're in the WASI part of the Rust target?
Yeah. This is the Rust sys implementation for WASI. So this is specifically the networking implementation for WASI.
Yeah, I haven't spent much time inside the standard library, so I wasn't sure how it separated out all the different libraries for the different compile targets, but this makes sense. Thanks.
Yeah, they're completely separated. So once we build a Rust toolchain and standard library with this, we can basically try to build a WebAssembly module that just imports a Rust TCP stream. And if you build the entire Rust toolchain, a stage 2 build compiler with LLVM and the Rust linker and everything else, you are able to have a Rust compiler that can build WASI-32 that has the patch that we applied, and that builds a live Wasm. And if we run that, we have to start on the right port, and yeah, essentially you can multiplex on the Rust TCP stream, and this is just a user error that it doesn't have enough. That's a nice way to patch that. Well, for some reason that fails, but it essentially it's able to connect and to send messages back and forth through the standard library. So that's a user land error and not a networking error. So in short, this is trying to add Berkeley sockets to WASI in a in a way that should probably not be used in production right now. And I would recommend people watch the official API that takes into account capabilities and everything else.
That's pretty cool, man.
Do you mind giving like a 10-second over a couple sentence summary of what capabilities are currently on the table that they're going to add? Do you know, is it going to be port ranges, IP ranges, domain name range?
In short, it's first of all the capability for a module to actually request a socket, to actually connect to a socket, and then there's IP ranges and port ranges as well. The main, go ahead.
I was going to ask if they were going to split between client and server and if they were going to implement them separately.
That was the next thing I was going to say, that this works great for client connections where you have an HTTP client or an HTTP2 or UDP maybe, or whatever client connection you're trying to make from your WebAssembly module. But for actually starting a server, this is probably not ideal. And the reason for that is because you don't have multi-threading at all in WebAssembly. So unless you're okay with having single-threaded server listeners, then you're probably fine, but it's maybe not ideal for now.
If only there was a multi-threaded runtime that hosted single-threaded WebAssembly modules. If only.
Kevin.
Yeah, I haven't heard of one.
Tell me more. Radu, this is awesome. Thank you so much for all the time on this and sharing this. Anybody have any questions?
I actually had, so the WASI stuff right now is, you said that the debate had sort of cooled off a little bit. Do we know if there's sort of a timeline for when that's going to stabilize? And if so, when will this, the Berkeley socket stuff make it into multiple engines like Wasm Time and Wasm 3 and things like that?
The good part about the open PR on the WASI API is that it comes with a work in progress implementation into Wasm Time. So if you want to take the current state of the API and build upon it, there's a fairly good starting point in a work in progress branch. Timelines, I have no idea. There seems to have been a sort of a dial down on the discussions in the PR around October or so, but there seems to be consensus. So we should probably bring it up at the next WASI community meeting.
Yeah, I think there was a lot of social dislocation starting somewhere after October.
And I think kind of a follow-on question there is, do we know what the timeline is for the Rust standard library to start emitting this type of WASI-based code without us having to fork it?
I don't know. It's first of all, this thing has to be stabilized into WASI.
Hey, Radu. Well, awesome demo, by the way, and clearly was a huge fit with all your fans. The only suggestion I had beyond any other questions were if you wanted more feedback on that, was to maybe bundle it up into a Docker container so that others could just pick it up. There's such a big barrier to, like building your own Rust and compiling everything. But then again, maybe if you're not going to go through that, you're not really going to contribute at the level that you want anyway.
Yeah, building a stage 2 Rust compiler takes quite a bit of time. So I don't think everyone will want to do this. At the same time, I think if we want to meaningfully contribute to this, we should probably be looking at the open pull request rather than my put together implementation for this, mainly because that's complete with capabilities and everything else. To answer Kevin's last question, given that this has to go through a period of stabilization in WASI and then Wasm Time before making it into the Rust standard library, honestly, I don't think it's going to be in the next few months. Definitely not.
Awesome. Any other questions for Radu before we move on?
Yeah, I had a question, Radu. So are you planning to submit a proposal on the on the WASI repo, or are you piggybacking on the current PR that's in there?
I think the current API PR also has a working, or at least the start of a work in progress for Wasm Time. So
Okay.
I would be more than happy to contribute to that, or if that is not updated anymore, I'd be happy to work with people to start a new one.
Okay. So from my recollection, this got talked about a few months ago, the Berkeley Sockets thing, and I think everyone's like, yeah, we need something like this. We need something, but there was concern. Someone had concerns about security and about exposing IP addresses in like the Socket Connect call. They wanted it to be something else that was more secure. And I felt like at the time, if there was someone who really wanted to champion this proposal and drive it all the way through, I mean, this could probably happen, right? Because someone just needs to talk to that guy and hash it out. But I don't think at the time anyone was really signing up for that.
Yeah, I think if we bring this up again at the next WASI meeting, I'd be more than happy to offer to at least start something or work with other people. I'm more than happy to do that.
Cool.
That's awesome. Well, thank you again so much for the demo. I think it's really cool to share what you're working on with others in the community. And I'll cut this up and also put a link out on Twitter, Radu, so you can maybe try to point a few other people at it and get some more discussion going. Notes from our last meeting are posted, by the way, up on GitHub, along with the lightly edited call recordings. If anybody needs to pivot back or is curious. Wasm Time has another meeting scheduled for next, the 24th. I anticipate that will likely be canceled, but a meeting agenda is already posted. And then all the blog posts are linked here. And actually, real quick, I wanted to, Andrew, what I hope to do is rope you into a demo of WASI-NN, maybe on our next call, whenever that is. But I wanted to make sure that everybody had seen your great blog post that went on the Bytecode Alliance here. Is there anything that you wanted to comment on this? And I'm sorry, Ming-Shu as well. This blog post is great. Anything that you guys wanted to comment on here, just quickly?
I don't know, Ming-Shu. I mean, well, the one thing I would say is, obviously, I actually ran across this yesterday. Someone on Twitter saying, hey, why do we need WASI-NN? And I was like, yeah, that is a good question to answer, right? Because I don't think people, I think when people think of WASI and system interfaces in general, they think of like opening files and opening sockets and stuff like that, right? And I think we should have a conversation about that at some point, because from my perspective, like working at Intel, there's a lot of system functionality that I feel like is at the system level when it comes to machine learning stuff, and that doesn't, I try to explain it very briefly in the blog post, but like that currently isn't going to be exposed in any way by, like, for example, Wasm SIMD. So the max performance, like if you have an accelerator, or if you want to use a GPU for machine learning, I mean, you're just not going to be able to do it for a long time. And so this is the only way that we could see sort of short term to get at that functionality, and we had to put it at a system level interface level. But I sort of want to discuss it more, because obviously this is just the first step, and we might need to. We're actually quite open to changing this and modifying it based on people's feedbacks.
So one of the, sorry, go ahead.
Oh yeah, so just in addition to what Andrew was saying, the approach we took in, the model loader API, meaning that we just load a model and then execute the model. So we got some community feedback on like what's the next step. Some framework writer, for example, they think like specific operation acceleration is more important to them, because they don't need to have the whole framework supported, right? But they can compile into WebAssembly and having a few operators, accelerated at the hardware level. So that's kind of direction we're looking for the next phase. And we definitely want the community engagement to try this, what we have implemented already, and idea for improvement for the next phase.
Well, and you guys did a reference implementation here with OpenVINO, right? But this is fully pluggable, so somebody could plug in TensorFlow or, whatever the case is, right?
Yep.
Yes.
The one question I had, and I know that this pull request has already been merged into Wasm time, your pull request there, so that, this is out there, was, did this really fit at the WASI level? To me, like in my simple mental map, I always feel like, Wasm's my CPU. And then on top of that, I've got WASI, which gives me some of my OS type stuff. I almost felt like this would be, this is definitely needed, but I almost felt like this was maybe outside of where things might go for, WASI. Did you guys think about like where this framework would sit, or were you trying to drive it into WASI just to get adoption faster, or what was the kind of thinking around that?
Well, I would have preferred to have done a lower level API for WASI, right? Like a WASI GPU or a WASI TPU or what, something like that. Like, I don't know what would be in those calls, but right. But the problem is right now, machine learning, the ecosystem's moving so fast that API would be quite unstable. So there's I heard somewhere that TensorFlow has like thousands of operations, like distinct operations that you can put into a neural network, and that's growing by 20% every year. And if that's the case, like we cannot keep up. We can't keep our API up to date with that many operations if we were going to do something at a lower level. So we said, well, okay, I guess we'll have to do a higher level API just to enable the functionality in the short term. And I had quite a few discussions with Dan Goldman about this, because the goal would be eventually to have that lower level API and to sort of implement WASI-NN as it is currently with the lower level API. It's sort of become a shim instead of like right now it's the only way you can get this functionality, but eventually you'd have the lower level API, and it itself would implement the higher level WASI-NN one. So I don't know, that's sort of the thought.
Right. So the way I see it, this is like a very similar to early stage of a browser, when you have like a different encoding format for image or video, right? So instead of trying to understand the actual encoding mechanism and implement those detailed steps, I think the browser approach was that we don't really care about the actual image encoding, right? We just take the image, which is a model, and throw it to the hardware. Let it, decide what to do with it, right? So I think this may not be a bad approach, and just assuming that the hardware actually understand the model, right? And we are the middleman. We just pass along this model, and then let the hardware decide what to do with it.
Yeah. So for me, I think the confusing part was or is the WASI prefix. When you first see it, it's for me. I was trying to figure out whether it is a part of WASI or whether it just depends on WASI. And from what I can tell from the API, I think it basically depends on WASI because you need some file-based stuff in order to do the model loading.
It's a part. It's an extension. The exact thing is it's an optional extension to the WASI interface, but it's optional.
Okay,
so it's optional, but it is an extension.
So that sort of gets at the heart where I'm trying to go with this is, if it's optional, does that mean that? So it's an optional extension. It still requires WASI, right? You can't use the machine learning stuff without enabling the rest of WASI, right?
I guess there would be a way where you could do it separately, but I have never really thought about that. I always thought about it as going along with the rest of WASI, the rest of the WASI proposals.
Yeah, and so the thing that I like about the imports mechanism in WebAssembly is how it lets you keep the dependencies as isolated as possible. And so when I thought about how you might slot in these different implementations of the machine learning stuff, I don't know how WasmTime is planning on doing it, but one thing that I would want to be able to do is to be able to get, you know, the vanilla implementation of WASI provided by some plugin, and then the WASI-NN stuff be similarly swappable, so that I could choose the implementation on it. And it feels like now the way that it's headed anyway is that WasmTime is basically going to be your only avenue into which you can get access to WASI-NN. And what I'd like to be able to do is choose my core WASI provider and choose my WASI-NN provider, regardless of what the WASI-NN thing is called. So that way, you know, if I would want to be able to do the machine learning stuff on straight up bare actors or WebAssembly modules that have none of the other WASI functionality enabled. So I don't want them to be able to open sockets or read files, but I still want to be able to load a module out from raw bytes.
So I can't talk. So we have thoughts about that and plans to do something like that, right? I don't think at Intel we want to get in the business of like supporting every single VM, you know, a different implementation of WASI-NN for every single VM. Like that would be like crazy, right? And if we had such an implementation where you could just sort of plug it in to WASM3, to WasmTime, to Node or whatever, I think that would be the optimal place for us to be in.
Right, that's what I was getting at.
Yeah, I think that's a great idea, Kevin. In the short term, though, I mean, we just wanted to try it out somewhere, and you know, I have experience in WasmTime, so I thought, hey, let's see what works here.
Yeah. So you know that there's the spec part of it, which is really, you know, very simple, a few methods, right? And there's like a reference implementation, which Andrew did on WasmTime, but it does not prevent any other people, you know, to do their own implementation on a different VM.
Well, I think, you know, from the spirited discussion on this already, that there's probably a lot of opportunity to brainstorm with this group. And I was really interested, and, you know, we'd just love to also point out, you know, Radu's got a post here on some of his TensorFlow experiments. And Andrew, I know that you said that you guys had traded some messages on this, but I would really love to see, you know, where the discussion kind of goes on making this more portable and everything else. And again, I would love to rope you guys in on a demo, Andrew, or if you guys would be interested. Could we you guys up for maybe that next week? We'll probably cancel next week with Christmas, but maybe the week after. I think you'd get a lot of interested people. I mean, I'll follow up with you on offline on that.
Okay. I'll be back in January if that's probably the best time.
Okay, great. Great. So I know we're kind of short on time here, so we can kind of skip through a few of these. Ralph is out on the, he dropped already on the Crustlet crit follow-up, so we'll put a pin in that. Brooks, did you get your feedback on your pull request that you're looking at on the Crustlet follow-up here?
I saw Radu's face right as soon as you said it.
Push it. That was the answer enough.
I did get with Taylor actually in between last meeting and in this meeting and got my tests passing again. I think I just needed a rebase from the main branch again. So I got that and tests are passing. But yeah, if there's any other feedback on my PR there, let me know.
All good. All good. And then Jared and maybe Jordan and any others, we've got the kind of website laid out for how we want to relaunch, under the wasmCloud name. And I'd love to loop in a couple folks on a separate meeting because we're kind of short on time here on the to-dos on that. So if you guys are okay with that, I'll ping you guys on Slack and grab 30 minutes with you, and we can kind of lay out, all the steps and tasks that we need to get that moved over. We've picked out a nice template. The project's going to have, a real, I think a much more product type feel to it, with all the work around packages and everything else. It'll land you and explain the value props, have some quick start videos right there in the beginning as we look at sort of making the community a bit more approachable. And just a reminder, Ralph has been doing his list here of blog posts in the community. I'll make sure if you're Andrew, if yours isn't linked, and I'll make sure that we do get that linked in there. And then I wanted to pivot to the .15 release and maybe just do a quick review of what we've got open before we hit the next milestone here. Kevin, you helpfully dropped a bunch of tickets here for some actor interface stuff. And you maybe want to do a quick overview of what all these are here.
Yeah, so these are basically, 15, 20-minute tickets or issues, whatever you want to call them. We're using the code generator to convert the WDL schemas into modules for these specific languages. So we've got Rust, AssemblyScript, and TinyGo. And the basic idea is that we have these small modules that actors use if they want to interface, if they want a specific host interface. So if they want the web server, or if they want the key value store or graph database or any of those, in the old version of WASC, you would essentially declare a dependency on a large monolithic SDK, and now it's basically just on these tiny wrappers around the generated types.
And is there an example in here, Kevin, that people can look at if they're interested in kind of toying around with one?
Example, actor interface? Well, there's 3 fully functioning Rust ones in there right now.
Yeah.
And there are some code generation samples in the WAPC GitHub org. We just haven't gotten those samples moved into wasmCloud.
Okay. And Phil, I don't think you're on today. Phil Ketty. All right, well, we can follow up with Phil afterwards and see if he can maybe give us a little guidance on that. And then over to Brooks, we've got the remaining work on the wash up REPL here. Do you want to do a quick update on that?
Yeah, sure. So there's a couple of good things going on with Wash. I can do a demo shortly today, or I can skip it. But probably, like, long story short, what I'm going to try to do is roadmap out a 0.2.0 release for Wash, which includes the REPL and essentially all the functionality that we want to come with the wasmCloud 15 release. So that's mapped out in the wiki, or you can see it wherever milestones are in the repo. The REPL is about to be merged into main with that functionality there, including being able to call actors and link actors and providers. And I've marked a couple of these issues for that release as well, so that when we release wasmCloud 0.15, we can also push out this very distinct version of the command line tools that we're packaging with it. And that'll give us a great starting point for writing documentation and tutorials and getting people using the product in a way that is good and easy for the developer experience. So once we get that out, I am going to be really excited to see what people think about our documentation and the experience with the REPL. If you're interested in trying it out now, I put a post in the wasmCloud channel in Slack. So that is available if anybody wants to play with the REPL as it is today.
Thank you, Brooks. I know we're all really excited about the work there. And Bill, we've got, I think, 2 here for you. We've got the homebrew stuff. I don't know if you have any updates on how that's going. and then the automation for builds on check-in into main for wasmCloud repo.
Yeah, sure. So as far as Homebrew, we created a Homebrew wasmCloud repository. Currently it has Wash in there. Also added a GitHub release CI workflow for GitHub to basically create a tarball release of the wasmCloud repo, which we can then use to create the formula for wasmCloud.
Great. And then on the, okay, so then that covers the release piece here, that this work is in flight. You know, we've got the, is that what I'm hearing? We've got the builds kind of sketched out here, and we'll get it all wired up in the next week or so.
Yeah, so theoretically, this is all wired up already. It just currently it's relying on a tag action before it actually spins this up. So in order for this to spin up at the moment, we need a GitHub tag. So that could always be modified if we want to.
Okay. Kevin, any feedback or suggestions on this? You know, should we be building on every merge into main, or, you know, or should we have like a, I'd asked earlier about, you know, like a release and a main, you know, like nightly build, you know, whatever.
So we don't need a nightly build. We don't have nearly enough consumers to warrant such a thing. What we're talking about with that with the build issues is that on this one, there are a couple of these release actions, but we don't actually have the regular building actions. There were some build actions that the old West Coast used to have that haven't been migrated over or upgraded. So basically, just for consistency, we need to make sure that for all of the repos that we have that are involved in all of our release pipelines, that every one of those is building and testing on commit to main as well as on the pull requests.
Okay, maybe would you just drop in a issue and link those to Bill, so he's just got the list there.
I think I actually did see an existing issue for those, so I can tackle that, Kevin. So theoretically, I should be able to mostly copy paste the West Coast CI over, and then maybe just touch it up a little bit.
Yeah, it'll probably need some touch ups because the directory structure isn't the same, some of that other stuff, but the annoying parts that took us a few days to figure out how GitHub Actions worked, those should be copy and pastable.
Awesome. Yeah, I can take care of that.
Okay.
Oh yeah, sorry, Brooks. I just saw your comment. Just for so basically, in the wasmCloud and Wash repositories, we added a local a hack directory essentially that contains a Docker Compose file, which can be used for local development. So just wanted to throw that out there.
Okay, sweet. I'll make sure that we link that into the notes too on the Docker Compose. I think that's super helpful. And then on the Azure Registry, right now our Azure Registry is wasp.azure. Whatever IO or something like that. We have created the new one called wasmCloud, and we're waiting on them to enable public polls. And then I'll set up a separate meeting to follow up on getting a website over for that. And the last thing I think we have on the agenda is a quick check-in on the iteration for the new .15 demo experience. And I know that Brooks, you were putting some comments in here as we filled in some of the yada yada yada, and all this stuff became real here. Anything you guys want to add or call out on here?
One of the things that I had a question about was more with Wash and what is being referred to as the REPL. It was unclear to me when I first jumped into it what the REPL environment actually was. Before I had used it with the talk, I assumed it was a REPL for all of Wash, but none of the Wash commands actually worked in the REPL. It was some subset of commands. So I think there's a terminology and opportunity for confusion there when it's described as a REPL, but the environment is not as intuitive as people would normally expect out of a REPL.
Yeah, so the ultimate goal with the REPL, which you get to through running wash up, the ultimate goal there was for everything that you can, the requirement is that everything that you can do from the wash command line in a single statement, you can also do from inside the REPL. And the other requirement is that everything that you can do to and get human readable output from the command line, you can also do to get JSON-based output from the command line. And I don't know if we have issues tracking that, but I know we're not feature complete on having all of the wash commands available inside the REPL.
Okay.
We've been focused specifically on the parts of the wash REPL that are involved in the demo script, so basically manipulating the host. And so some of the other stuff like signing keys and things like that haven't been put into the REPL.
Okay. So the expectation is that anything that could be wash blah 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 could also be just the blah 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 in the wash REPL.
Correct. There should be parity there.
Jared, great feedback, though. I really appreciate you taking the time and running through some of those tests. And I remember I saw your comments in Slack the other day, but thank you very much for contributing and helping. That's awesome. So back over to our list. I think we covered the key pull requests and issues. Kevin, was there anything that you wanted to pull up here and maybe just like point people at or talk through? I know we dropped a few tickets for like stress testing and stuff like that.
No, there's not really all that much that I wanted to go through. I mean, we're pretty close to, if not functionally complete on the new wasmCloud host. So now it's just dotting the I's and crossing the T's and making sure that everything is tested and everything is automated. So that going forward, we don't have any issues.
Okay, that's great. And I've tried to put a list of interesting demos and some topic backlogs here towards the bottom. This is all publicly editable. So as we saw with our little experience earlier, feel free just to drop in and add your own little participation here if there's anything that anyone else would like to see. But as we, I think the next few weeks look like, feature complete on .15, and then some effort around the documentation and the writing and those components, and then possibly onto, some of the more advanced tutorials and demo, little video recordings as we look at Kata Coda tutorials and things like that. So certainly an exciting few weeks ahead of us, and it should make the ecosystem a lot more user-friendly and easy to use. I guess I'll do a quick open call or any feedback or anything we want to change for next time, and then we'll stop recording.
I mean, I did want to bring up one thing that we had happen this week that some people here might find useful.
Please, go ahead.
So this week released Bindle. So you may have seen that on the interwebs. Which is just some experimentation we're doing around, it's for WebAssembly modules, especially when you have like multiple WebAssembly modules that end up, thank you, Radu, for sending that. I am currently on my phone because my Windows machine, I'm on my Windows machine, which is not my MacBook and doesn't have a webcam. And so anyway, but yes, so it is a aggregate object storage thing. And so the idea behind it is that you can store things that are whole aggregate applications. So for example, in a wasmCloud context, if you wanted to have these actors with various providers that they could use in different circumstances, those could all be stored within the same bindle. So right there, the silverware drawer is the example. So you don't store every type of silverware setting in its own package. So you don't set up like your fancy dinner thing with forks that you use at 3 other meals, all in separate packages. Instead, you put it all together. And then when you need to put together, let's say, a fancy dinner, you pull out your fork and that one kind of soup spoon that you need, and a teaspoon for stirring in something to your after dinner coffee. And there could be 4 or 5 different things. Whereas for breakfast, all you need is just a single spoon. And so those are the kinds of things that especially in the WebAssembly world actually is a very good analog for what can be done. And so this is something that's just an experiment right now, but we found some really interesting use cases for it. You can look at the introductory blog post on the Deus Labs blog that kind of does a little bit more detailed explanation. And there's also a WebAssembly doc in our docs directory of the repo. And that one is kind of a more long form example of what we envision using using Bindle for. So anyway, we'd love to hear people's thoughts and ideas, and if they like it and any feedback. Bindle is a specification as well, so it doesn't have. This is the Rust implementation that's supposed to serve as the reference implementation, but it can be implemented in any language. In fact, I think if it's not already open source, Butcher will be doing it soon. We have like a Node.js one that consumes Bindles. So we have a bunch of different things that are out there that we're trying out with this. So anyway, just wanted to throw it out there. Like I said, kind of dropped last week after the call. This is kind of adjacent. It isn't necessarily directly related, but it could enable some really interesting use cases.
Yeah, this is pretty cool. So Bindle as a spec or as an implementation is the bundle of files, the compression that's used for it, and then I'm looking at, is that a manifest file of some kind, or? So
yes,
it's essentially the metadata that describes the bindle and then the contents of the bindle, right?
Yeah, so a bindle is the whole collection of everything, and a bindle contains an invoice, which is like the main description of what are the things that are contained in here and some useful metadata. And a bindle will contain a list of parcels, parcels and labels. So parcels are the actual files or objects or whatever they are that are involved here. So a parcel consists of a label, which is the metadata about it, and then an arbitrary, it doesn't matter what it is, it's just an arbitrary file, binary, text file, could be anything that's uploaded to the server. And then you're able to, there's a filtering mechanism that's built in there right now. We're going to keep iterating and adding more to that allows you to select a certain list of parcels based on the features you want activated. So basically the set you want. It's the whole breakfast. Like if I want my breakfast feature, then I'll get something that only gives me the spoon parcel. If I have my fancy dinner feature, then I'm going to have something that's like a spoon, a fork, a knife, and all these different things that allows you to filter through it.
We ended up creating our own something very similar, because we needed to be able to bundle all of the different OS and CPU specific versions of the capability provider binaries into a single file so that we could then upload them to an OCI registry. So essentially the only real difference between what we did and what you have is what our metadata looks like, and the fact that we have embedded crypto signatures in ours. But
we have a thing on signing in there too, Kevin. You can take a look at our signing doc in there for kind of what we have planned for the signing.
Yeah, because we basically have inside our file, which is called the provider archive. Inside that we have a signed JSON Web Token, which has the credentials and the signature, and then it has the list of all of the files and the OS and CPU tuple that we use in order to retrieve the binary, the binary that we need for loading. Do you have some form of metadata that we could put on the individual parcels so that we could tell which OS and CPU they belong to?
That's the features part of it. So features is metadata, and we called it features because it's specifically like meant to be used where, okay, what's the OS, what's the architecture, what are the conditions needed for this, and you're able to filter on those features. We figured you might like this, Kevin. We actually even mentioned wasmCloud in the introductory blog post so that we think it might be useful here. That's why we would really love any feedback that you all have around.
I think my biggest thing of feedback is you should have told us about this before we wrote our own. So.
You can bring that up with Butcher, but we hopefully this is something that we can reuse and kind of standardize on with some ideas. Like that's why we have the spec is because we want it to be like something we can discuss in a spec and not lock people into having it just be Rust.
Yeah, I think of a worthwhile experiment, and we should probably put it in, create an issue for this inside our capability providers repo, is to see whether or not we can represent the same amount of data that we're currently using in what we call Pargeesi files as a bindle, and then we can sort of use that as beta tester feedback on the spec and the implementation.
That would be great. We'd love that. But yes, this was such an experiment that, like, we apologize that we didn't say anything sooner, but we didn't really have this solidified on kind of what we wanted the whole spec look like until about 2 weeks ago. So I do know that definitely figured into it.
No, this is awesome. I think that we should definitely do a proof of concept with Pargeesi's as a bindle. One thing that I saw that looked super awesome as I'm scrolling through the repo is that bindles are immutable once you form them, which I think is even better for us. Once we sign and push a bindle or Pargeesi, whatever, there's not much of a use case to modify it later on, and that guarantee is pretty neat.
Ours are essentially immutable. You'll break the hash on ours if you mutate them.
Mm-hmm.
Yeah, and ours uses mainly the idea of the name. The name is an arbitrarily pathy string, and version is it's a hard semver requirement. So it's very strict, actual semver requirement that's used. And then we stole the idea of yanking from crates. That we really like that concept. And so the only thing you can do to a bindle once it's once you publish is to yank it. And so that's pretty much it. So it is immutable, and we're keeping it that way. But I'm really curious. I think I'm guessing based on what you said, one of the few gaps might be just how you are approaching signing and what we would need to do to be able to handle that signing approach, or if our signing approach works or whatever. But yeah, like I said, I think this will be useful on for everyone here, because I think it really models the WASM module conglomeration really well.
This is awesome.
I've got a quick question. I know we're over time, Taylor, but with a bindle, is there backwards compatibility with an OCI compliant? Are they OCI compliant? Could you push a bindle to an OCI registry, or do you need something else to handle them?
No, we have not done that yet, but we assumed when we were writing this that someone would immediately want to, or that we might even write an OCI shim layer. The idea here is that this is not supposed to be a takeover for what OCI does. It's just supposed to be a different way of approaching dependencies for just dependencies, really. Dependencies for binaries, dependencies for that, not just layers and how those layers associate. So the OCI component here is not there yet, but we've discussed it, and we don't think it would be extremely difficult to have a shim between a bindle and an OCI compatible layer. The big thing you're going to get over using bindle natively is that you don't have to fetch all the layers if you don't need everything. So if you're running something on a more constrained edge device, you can get the lighter weight parcels based on the feature selection that you do, and never even have to touch the heavier weight stuff at all.
What we're doing now with our files is our provider archive file, we're just sending up as a single layer. And so we're getting it down, we're pulling it down as a single layer as well. So
yeah, which is what we do in Crestlet too.
Yeah, the least that could possibly be done is to treat a bindle file as a single layer. But yeah, I think looking into being able to separate the parcels as layers so that you can then pull from an OCI registry based on feature, that would be pretty neat.
Yeah, see, that's what we're hoping that this can help with for that specific reason, is that layers just aren't a good representation for this kind of aggregate application. So that's one of the big reasons, and we thought it would be useful to talk about here. Anyway,
one question I have, Taylor, is that if we're bundling, all the components together, are we kind of reintroducing, that one of the flaws we see with containers is that you have components that you need to keep up to date and version out and all that kind of stuff. that gets stale because it's like packaged over here in this container, something along those lines.
I don't think there's necessarily, my understanding of it is that there really isn't, this isn't built as a solution to that problem. Like you're still, if you have a new dependency of like you're a provider, like you need a new provider version in here, and it's represented in the bindle, then you have to push a new bindle version with that parcel referenced in the parcel list. But the thing is,
the bindles are internally cohesive or internally consistent, right? So you can't create a parcel that refers to something outside, which is essentially the flow I was talking about in containers, where you can have a Docker image that has a slice that can be replaced on you without your knowledge.
Yes, exactly. We're trying to avoid that because once you can't, because they're immutable, nothing can change in that parcel list. And that's kind of the basis once you look at our signing thing, Kevin, about like how we're using that. Because if you sign the whole, because everything's immutable, if you sign that specific information, then you're assured that it's not changed. And so there isn't going to be like some weird like inserting of another dependency, if that's what you're referring to. It's not going to solve the fact that I still have to update those dependencies properly, but it will make it so that like it should also say that the extra benefit here is that it saves on that use of bandwidth and things to store locally when you're pulling these things down. Because if you already have a parcel, that SHA for that parcel is immutable and will refer to the same thing. So if there's 3 bindles that all refer to the same parcel, then there's no need to upload it again, which exists partially in OCI, but gives you a better ability to filter and pull down those proper ones.
Okay, that's awesome. Well, we are over on time. I really appreciate everybody's patience today, and we'll have that addressed moving forward. So just a quick show of hands. Do we cancel next Wednesday, which would be the 23rd, or do we keep it on? I don't know if people want to maybe vote thumbs up to keep, or no vote. We'll assume we'll kill next week in favor of the holiday.
I think we kill the next 2 weeks, honestly, and just come back in the new year.
Yeah, I was about to say that more than likely, I'm speaking for myself anyway, my updates are basically going to be I've done nothing. And then the next week will be I've done more of the same. So
excellent. Well, let's plan on just killing the next 2 weeks then, and then separately I'll do a call in Slack for anybody that wants to hop on and work on website stuff. And try to knock that out. Maybe over break would be a goal for me. If anybody wants to jump in and help, more than welcome. There's plenty to do on moving documentation over and the new structure and stuff like that. But great meeting today. Awesome contribution. I think we're really picking up a lot of momentum, folks. We'll catch everybody later. Have a great week.
Take care, everybody. Happy holidays.
Bye.